Patrik Fältström. I'm head of research and development at Netnod. I've been here almost 4 years now, so I think I'm not allowed to say I'm a newcomer. Instead, I presume that you would like to know what I actually managed to do. So here's one of the things that we have been working on for a couple of years. This is to be able to succeed, I think that's a newcomer's issue. This is actually the second try that we are doing some NTP things, and this time we succeeded. I would like to thank everyone that was involved in both the second and the first round for all the work that you have done. I know some people in the room that have been helping us, consultants and whatnot. So anyway, so what are we doing and why? So time is pretty important, and you know that some of us at Netnod and some people sort of connected to Netnod, like Peter Lötberg and others, are really, really interested in time issues. But why is it important? This is one of my favorite pictures that I took once. As some of you know, I was an advisor to the Swedish government between 2003 and 2014. So that was 13 years in the government offices in Stockholm. This picture is from Rotundan, which is one of the main meeting rooms in Rosenbad, which is the Prime Minister's office. I took this picture about 2009. And most people that I like when I show this picture, I see it in this room as well, people start smiling. And even you don't have to be a time geek to understand that there is something weird in this picture. There's something in this picture that is there's something wrong here. I think this is pretty embarrassing that the Prime Minister of Sweden bring other heads of state to the room where the time show is this. Okay, anyways. So something needs to be done, but of course that the clocks are wrong in the walls of the room doesn't really matter. So what is time? Time consists of two things.
I need to interrupt.
Maybe people watching online cannot see my slides. Maybe that's a positive thing, I don't know. Okay. I look at the screen over there, mirrored. So if I speak backwards or mirrored, in that case, it's not my local dialect. So anyways, time consists of two things. So this is not so hard. You have something that says tick, 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 like a pendulum, and then you have a counter. And you have both of those together, then you have a clock. The problem here, of course, is that to have two clocks to go to be in sync with each other, you first need to have the tick in sync, and then the counter has to be in sync. So, and the tick is of course kind of hard to get in sync, because either you need to, if you have two pendulums that go that doesn't go in sync, either you need to stop one of the pendulums, or you need to add a delta from the tick that you get from the pendulum so that you have a resulting adjusted tick, which is the pendulum plus a delta that is the same for the two pendulums. For the counter, the only problem is when you boot the clock and you get the tick. When you get the first tick, you need to know what number that is. So that's a bootstrap issue. So these kind of things are sure, doesn't sound so difficult, but if you try to do this with high precision and high accuracy, then you might have an issue. Because you can have high precision, high accuracy, low precision, and low accuracy. And what we want, and as you will see, what we are requested to do is to have high precision and high accuracy. And this is when things start to get a little bit tricky. So the first thing we need to know is that there are multiple versions of time. We have different time scales. And some of them add something called a leap second, some of them does not, some of them depends on the Earth rotation, some of them do not. Of course, the time all of us have agreed on using is something called UTC. That is nowadays a stable time that is linear, but we at the same time try to make it adjust to the Earth rotation, which is not stable. And we do that by adding or removing leap seconds now and then, and we did 1st of July this year. There is, by the way, discussion in the ITU at the moment whether we should continue with leap seconds, and if we don't, what to call that time scale. It's a big mess. Anyways, so UTC is the time scale that we are following, and that is also what we at Netnod is presenting. The official Swedish time is the version of UTC that is produced in Borås at Statens Provningsanstalt, SP. So how how precise and how accurate do we need time? The real problem we have, as I said, is when we have two clocks and we need to know how accurate they are and we need to reach a certain level of precision. An easy example is, for example, if Nuran and myself were going to one of the places where we go now and then, Brasserie Godot here in Stockholm. My experience as someone that goes out and drink beer is that I go to a place, agree with, for example, Nurani on a time and place. It's something in 4 dimensions. So first of all, in the geographical dimension, we cannot differ that much. We have to at least go to the same restaurant, so it's sort of plus minus or 20 or 40 meters or something, so we can see each other. But time, how accurate does time have to need? My experience, based on empirical study, many years of studying, means that 2 persons meeting to have a beer need to have clock. Hello? So if 2 persons go and have a beer, the clocks need to be accurate within about 15 minutes. And that is because it takes about 15 minutes for a person being alone, sitting with a beer and waiting for another person. When that beer is finished, you make a final decision of whether you should wait any longer. And normally, you actually might leave. So 15 minutes is sort of, in the human lifetime, something that is sort of precise enough. But so what we are trying to do is we're looking at events that are happening at various places, for example, multiple servers or routers. We have those events get timestamps. The logging of the events is moved to central storage, and the question then is, in what order did this event took place? If this is the definition we have of precision and accuracy, then we do understand that the accuracy and precision need to be much, much better than the time interval between the events. So if we now start to do trading of stock automatically by robots, if it is the case that we have logging based on the data retention directive yeah, or something else, it might be the case that it's pretty important that the timestamps are correct. There have been multiple issues why, when we actually had issues with timestamps. For example, the killing of the Swedish foreign minister at the department store NK in Sweden, that was actually what made the society wake up when we saw that the timestamps of the video cameras were so different and the cash registers, so the police could not use directly the timestamps of receipts to know and trace how the events happen in the department store. It took 3 days to just correct the timestamps of the receipts. So one can then question, so here in Sweden, is this something new that we'd like to have correct timestamps? No. One of the oldest laws we have in Sweden from 1736 says that if it is the case that someone sells the same goods twice, the first person that bought the goods, keep it, the second one has to return it, and the one who sold it has to pay a penalty. So already in 1736, in Sweden, and by law, it is really important, it's important in Sweden to know in what order transactions took place. And now when doing digital transactions, it's even more important because you can really sell the same things twice, whatever that means. You can sell something and then, yeah, anyways. And then, of course, you have the Euro SOX and other kind of legislation that require this. So this is what we have at Netnod so far, that we have had more or less for fun, that has been cross-subsidized from the income from our paying customers for DNS and IX. It's using rubidium clocks in Stockholm, Gothenburg, and Malmö. And this is sort of pretty okay, but not high enough precision for example, for you to pick up the time from us, because many of you have clocks that are even more accurate and better precision than what we have. As you see on this is sort of the result of how accurate our clocks are. You see that we are within 10 to the power of -6 seconds. But on the other hand, you also see on this that we have to make adjustments like all the time to make sure that the clocks are precise enough. So this is simply not good enough to use as a time source or a reference clock in Sweden. So what happened was that about the last 10 years, the government had an investigation that in 2006 resulted in saying this time thing is pretty darn important. And in 2012, some which is a cooperation between agencies in Sweden, decided that time and frequency is important for the Swedish society. And it's also the case that we have so much jamming of radio, so communication in Sweden in general must be able to boot and work without radio communication working. And this is just because of jamming of GPS and other kind of stuff. So PTS, the regulator, said, we take responsibility to make sure that there is one time and frequency source in Sweden that everyone can use for free if they so want to, if nothing else, to compare with the time sources they have. This resulted in cooperation between the Institute SP that is producing time in Sweden, the UTC SP, and Netnod. And together, we are cooperating, and Netnod has been running a project for some time, as I said, that PTS is financing, and we are to produce NTP, 1588 V2, and frequency, so both time and frequency for free in Sweden. So this is a copy, this is from the agreement, where it says that we should be able to develop, to deliver these kind of things, and that the actual, the SP is the one that is going to measure and make sure that what we are delivering is up to the quality that they require. The quality they require, I don't know whether I have a slide of that, is that we should have clocks in Stockholm, Gothenburg, Malmö, Sundsvall, and Luleå. Luleå will not be installed until next year because of the lack of space there. Stockholm, Malmö, and Sundsvall is installed. It's not really up and running because we're still lacking some antennas. Gothenburg will be installed now in October. We will deliver the services no later than December 15 this year, and at that time it will be up and running. So we are looking for people that would like to connect to us. Either PTP or NTP. NTP is over V4 and V6. It will also use symmetric encryption for the NTP, so we have to do a handshake of the keys. But those who would like to test that, we are interested in testing that as well. The precision and accuracy of these clocks is that the requirement is that each one of these nodes must be within 250 nanoseconds of UTC SP. So it should be accurate and precise enough for you to use it. It's also the case that each one of the nodes must be able to be within that precision, even if it is disconnected from anything else on the planet for 6 months. So they are self-sustained and 250 nanoseconds precision. So we have developed NTP server in FPGA. It is completely redundant. It is 10 gig, multiple 10 gig interfaces for each one of the NTP servers. We use so far one profile of PTP 1588. We really would like to hear input from those of you who run 1588, what kind of profiles you're using, and what you want. In meetings with the regulator, we understand that the various in the mobile, even among mobile operators, there is a little bit difference what kind of profiles you would like to use. Vendor specifics. We also provide frequencies 1 packet per second, 5 and 10 megahertz. So what we do is that we are using satellite to compare the time and tick between the nodes just like before, but we're also going to use, that is what we're doing today. But to be able to be independent of radio, we're also going to use PTP over SUNET, and we are already doing that from Stockholm up to Luleå and back, so we are looping over the SUNET transmission. And then, of course, traceability. We have, each node has an A and a B side, and we are swapping automatically between the A and B side. We have UPS and electricity in the bunkers, just like you have, for those of you who are there. But on top of that, we have extra backup battery for the clocks themselves to make sure that we actually are managing to stay within the high requirement. Yeah, so 250 nanoseconds over 6 months. That's what we have managed to build. So I'm really happy to actually have this built. And those who are interested in talking with us, I really would like to talk to you, specifically those who run mobile networks and stuff, to be able to maybe not that you are completely using us, but at least you could sort of start to use a delta between what you have and what we have, so we can see how good time we have and what we have, all of us together in Sweden. Some references, some books that I think have been fun to read. And the last one, of course, I've written part of that book, so I think you should go for that. Anyways, any questions?
Hello. You mentioned designing the new server in an FPGA.
Yes.
Do you have an industrial partner doing this, or do you do this entirely by yourself?
We use the Vertex 7 card, which is kind of cool to work with. So, which of course you're supposed to maybe use the result of the development of the Vertex 7 card to then produce your own ASICs. We didn't. We just bought 15 development kits, so we're actually running on top of them. The actual code, we have a programmer that actually wrote the code themselves for the FPGA, and then we use some cooperation with staff of the Cryptech project to actually implement the encryption in the same FPGA. Everything we do will be available, including the code for the FPGA, so also others can use the same code and replicate what we have done. So in-house development for the FPGA. With the earlier project we were running, we're looking at 1 gig cards to use standard Ethernet cards, which can do timestamping. But when reviewing that, we saw that no, we actually would like to do 10 gig just to make sure that we don't have a packet drop on our side, unless we decide explicitly to filter traffic. And we couldn't find any good Ethernet cards with timestamp Ethernet packets. And by doing it this way, we have the NTP server itself implemented in the FPGA. So we don't have to use the CPU at all. It also means that the NTP server, for those of you who got scared that you have, those of you who know about the denial of service attacks using NTP, this server do not handle any of the control commands, because we don't need to. And that's where the denial of service attacks are. It does only respond to the NTP sort of time queries, nothing else, no control channel. But the answer to your question, the NTP server itself is implemented on the FPGA. We are not using anything in the operating system for that.
Okay, any other questions to Patrik?
Thank you.
No, well, thank you very much.